Alright, we're going to be taking a look here at what we call transformations, and as the word suggests here, we're going to be taking things and transforming them, shapes that is. So we have three types. The first is called a translation or a slide, where you take a point or a series of points and you slide them. We also have what's called a reflection or a flip, and finally we have a rotation or what we call a turn. And so typically what will happen is you'll somewhere you might have a figure on here. For instance, maybe it's a triangle with these three points as your vertices here, and if you're going to go ahead and connect them, I'm going to go ahead and do that right now. Go ahead and connect, 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 connect. You might be asked to rotate it or reflect it or translate it in some fashion here. And so what we're going to do here is, rather than actually do that for a triangle, we're just going to do it for a point here first. So let's go ahead and do that here. And we're going to use this point here, 4, 2. So 4, 2, 1, 2, 3, 4, 2. That's the original point here. We're going to take this and we're going to do a series of things to it, and we're going to see a pattern, and it'll actually hold true for all points. So the first thing we're going to do is we're going to reflect it over the x-axis. Well, the x-axis is right here, and so if we reflect it over, it winds up right in this spot. And the coordinates of this would be 4, -2. So I'm going to go ahead and write that there. 4, -2. If we reflect it over the y-axis, what will happen is, here's the y-axis right here, reflect it over, it'll be 4 over, 4 to the left, 2 up, so that would be the point -4, 2. So before we move on to rotating or translating, what do you notice here? Well, it's the same coordinates in a way, except there's been a minor change here. For instance, here the x's stay the same, but the y has changed sign. So in general, what would happen is, if you took that whatever x is, it'll stay the same, and then you just change the sign on y. For reflecting over the y-axis, the x changes sign. You'll see that there, 4 to -4, so it'll be -x, but the y stays the same. So that's a general pattern that'll hold true for any points here on the coordinate axis. So let's also now look at rotating. So rotating 90 degrees counterclockwise. Well, 90 degrees is a quarter turn, and counterclockwise would be in this direction over here. This is your x-axis, and if we were to rotate it 90 degrees, it would wind up right here on the y-axis. So you'll notice here, relatively speaking here, it's 4 along this axis, and then it would be 2 to the left from it. So if we count 4 here, we go 1, 2, 3, 4, and then 2 to the left of it. That would be our new point, and that would be a rotation of 90 degrees counterclockwise. And I'm sorry I didn't mention this earlier, but the origin is our rotation point. So the coordinates of this point would be -2, 4. So I'm going to go ahead and write that here, -2, 4. If we wanted to go ahead and rotate the other direction, what would happen is you're going to rotate this direction here, that's clockwise, and what was the x-axis now would become the bottom half of the y-axis here. And you'll notice here once again we're 4 along it and 2 in this direction. So 1, 2, 3, 4, 2 in this direction. The coordinates of that happen to be, that would be 2, -4. And finally, if we kept going here and went another 90 degrees, and it doesn't really matter which direction you go in, because 180 degrees is half a circle. Whether you go clockwise or counterclockwise doesn't matter. Once again, we're going to count along 4 here, 1, 2, 3, 4, and then left 2 from there, and that would be -4, -2. -4, -2. And so let's see what the pattern is. You'll notice here that x and y was 4 and 2. Oh wait, now it's 2 and 4. So they've changed spots here. So y and x have changed spots. And you'll also notice that the y was 2, now it's -2. So we would take the opposite of y, x. Over here on rotating 90 degrees clockwise, once again they change places here. So y, x, however this time the x changes signs. So that would be now a -x. And finally the last one, you'll notice here they don't change position, so there's still x, y, but they both change signs. So it'd be -x, -y. And like I said, this will hold true for all points here, regardless of what coordinate we start with or what quadrant we're in. Alright, so our final transformation is what we call a translation or a slide. So we'll take this point 4, 2 and go 2 to the right. So 2 to the right would be to right here, and then we'd go 3 down. 3 down would be down to here. So this point right here would be our new point, and that would be at 6, negative 1. So I'm going to write 6, negative 1. And if you notice here, what's happened is our x coordinate has gone from 4 to 6, so it's actually increased by 2 in this case. So when you go right, you're going to be adding 2 onto x. And if we went 3 down, you'll notice the y went from 2 down to negative 1, it went down 3. So it'd be y negative 3. So in general, if you go down, y is going to go down by 3 in this case here, but it'd go down by however much you go down. Now if we went a different way here, what if we went to the left instead of to the right? So I'm going to do that there. So I'm going to go left 3. So that's 1, 2, 3. So here's our left 3 to right here. And then we're going to go up 4. 1, 2, 3, 4. And the coordinates of this would be 1, 6. So I'm going to write that right here. 1, 6. And you'll notice here that what happened is 4 to 1, we went down 3, so that would be x minus 3. So anytime you go to the left, x is going to go down. And we go from a 2 to a 6, so when we go 4 up, we're going to take whatever y was and add 4. So those are just some general principles here that you can apply to any points whatsoever. So finally, to wrap this all up, let's go ahead here, and I'm going to go ahead and put in a triangle. Start over here in this quadrant. So here is my triangle. I'm going to go ahead and draw the lines in between them here. So here we go. And let's say the directions on this one here were to rotate it 90 degrees clockwise. Okay? So what I would do is I would take each point here. So here is point A and B and C. So A would be negative 8, 3, negative 8, 3. So if I want to go 90 degrees clockwise, 90 degrees clockwise means I'm going to flip my coordinates and then I'm going to change my x. So if I flip these, if I exchange places, I get 3 and I get 8, and then I want to go ahead and I want to change my x. So it'll be 3, 8. So this will become 3, 8. So 1, 2, 3, 8 is up here. That's my new A, and we call that A prime. B is, let's see here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it is negative 6, 6. And so what we're going to do then is change places with them, and then we're going to go ahead and, as it says here, we're going to change the x. So this will become 6, 6. So 6, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This would be B prime. And finally C. C would be, let's see here, left 4 up 3s. So that would be negative 4, 3. So once again, we're going to exchange places with it. So 3, negative 4. And we're going to go ahead and after we change that, this becomes positive. So it'll be 3, 4. So 1, 2, 3, up 4. This would be what we call C prime. So this would be a full rotation here of 90 degrees clockwise. And then if I went ahead and connected them, I won't use the ruler this time, but connect them something like this. This would be your new triangle here. So use these overriding principles here to hold true for anything. It doesn't matter if you're reflecting or rotating or translating. If you follow these principles here, what to do with the x and the y coordinate, it'll hold true every time.